Okay, so today we're going to talk about the big picture, why we're learning this stuff. Then we're going to kind of go over some simple factoring all the way up to the complicated stuff we're doing now. And then I'm going to teach you to factor 6-term polynomials. It's the biggest factoring that's done at the high school. You don't do anything harder than this like your whole time through the high school. So if you can handle this, you got one of the biggies that you're supposed to know. So big picture, why are we learning this stuff? Well, here's the big picture. There's you. You're right near that sun, and that sun of our solar system has got, how many planets are we down to now? They've thrown out a few. 8 planets. Okay, so there's 8 planets going around that thing, and you're on the 3rd rock from the sun, which of course you learned from that show. And the 3rd one out. What's the first one out from the sun? Mercury, and then what's the next one? And then us. And then what's the next one after that? Okay, all right. You guys got your planets down. That's awesome. But just picture this universe and all of those little white dots. Actually, this is the Milky Way, and it's made up of universes. You probably can't even see our white dot. But the white dots are actually like clusters of other white dots, which are all suns, because the only thing that makes light up in the sky are those suns, I think. I could be wrong on that. But if every one of those has planets going around it, just think about how many planets are out there. I mean, if every one of there's a bazillion of the suns, and then there's all those planets, and then of all those planets, shouldn't there be another one that's a lot like Earth? I mean, just shouldn't there be one that has like water and land and stuff? And unless you think there's aliens running around in every one of them, shouldn't there be a planet that's like really amazing and there's nobody living there? Like nobody, no humans anyway. And unless you like, and you like move in, and yeah, maybe it's like Avatar where there's all these blue people running around that own the place. Or maybe there's nobody there, and it's just like, if you could just move in, you could have the whole world to yourself. What concept? Yes. Good question. I think that's just, I am not an astronomer here, but this was a picture that actually came from NASA's website, so this isn't like a made-up thing. I think it's just how the different galaxies like look if you're a long ways away from them, like just like when you get up really close to a leaf. You know what you can look at a leaf from a distance and it just looks like a leaf. But if you get in really close, you can see the complexity of it. This is what our Earth looks at, or what our whole galaxy looks like, or no, not even the galaxy. It's bigger than the galaxy. I guess the universe. And they think it's expanding too, like it's getting bigger and bigger and bigger. I don't want to talk about this for too long, but so let's move on to the next thing. If we're going to think about you are here, like big picture, this could be your life. And you are like right in the middle of this part, which is like the high school part. And then you move up to the college part. I don't know if you can see this, but it says leave college right there. So the college part must be like right in here. So in the whole you are here thing, you're in high school, beginning of it, and you got a lot of stuff to learn before you even get to college. And then you get to college, you learn a bunch more stuff, and then you got your life, which can go in many different directions. Many ways to mess up your life out there too, but hopefully you don't do that. And at the end, it's got retire. It's kind of depressing. It makes it look like, okay, life's over with. You retired. I don't think it's supposed to be that way. I think there should be a whole bunch more branches after that, because then you got all this chance to go do interesting other things with your life. But in the big picture, I want to make a tree just like this for math. And some of the branches on the tree are more important than others. They really are. Stay with me now. The one we're doing right now, factoring, is probably one of the most important things you got to know on the tree of math. Really, factoring is huge, and there's a lot of reasons. The pre-calc teachers will tell you that the class after this, either pre-calc or pre-calc with advanced topics, PCAT, did they call it? Pre-calc or PCAT needs you to know factoring. It's one of the top things they need you to understand really well. Okay, and you guys are pretty good at it, but we spend a fair amount of time even getting up into really complicated ones because you use it a lot. You use it to find roots. Okay, so if I can factor this real quick, can anybody just do this in your head? What's this one? X plus 1 and x plus 1. Okay, so that means a lot of things. It means that the root is -1, and it's what kind of a root? Double root, which means what would the shape of the graph be at that spot? Be bouncing. Okay, and if it's bouncing at that spot, then is it going both ends going up or both ends going down? I know they're both going the same because it's even. Remember that? It's going up. How come you know? Because it's positive in the front. It's positive out here, so therefore it must be going up on the right. And if they're both going the same direction, they must both be going up. All right, so you know a lot about that. And basically, what allows us to do that? Factoring, because factoring helps us to find the roots. Now, granted, you can find the roots with the quadratic formula too. The quadratic formula helps with that. But factoring is really slick and a lot faster than the quadratic formula. All right, simplifying. If I can simplify this to x plus 1 and x plus 1 again, and on the bottom, can you factor that for me quick? X plus 3 and x plus 1. Very good. You guys are getting good at factoring. Then I can cancel those two things. You see that? And now, all of a sudden, it's a lot simpler than it was. My answer is x plus 1 over x plus 3. It's a lot simpler to deal with that. If you know how to factor, it helps you to cancel things. Next up, domain restrictions. If I do the same thing and I end up with x plus 1 over x plus 3, and those teachers that would listen to this would say, oh, but wait a minute, this causes there to be a hole in the graph. Yeah, I know that. No, they don't know about holes yet, though. I'll tell you about holes eventually. This is, yeah, you'll understand holes on the graphs later. This spot right here, I can put in any number I want to, except one number would mess it all up. What can't I put there? -3. Why can't I put -3 there? Well, what's wrong with 0? Exactly. You can't have a 0 in the denominator down there because anything divided by 0 is undefined. I can't have a 0 down there. So even no, it doesn't matter what came out on top. If it's divided by 0, it's not possible. So you have to say your domain would be all real numbers except x cannot be -3. All right, so it helps you with finding your domain restrictions. There's a ton of things factoring does that are good for you. And it all started with you learning this in probably 3rd grade, maybe 4th. You learned about a simple term, and that's an algebraic expression because it had algebra because it had this letter in it. Okay, well, can I factor that? Don't say no. Just think outside the box of what factors are. Okay, so then you know the answer must be yes. But can you actually tell me what it comes out to if I factor it? Yes. X and 2x is kind of right, except 2x can even be split up into what? X and an x and a 2. And I don't have to write it that way. I can write it in any order I want to. I could say x and 2 in the front, maybe. But those are the factors. Why? Because factors are things you multiply together to get the answer. Okay, so that's what I'd multiply to get this, right? So that's factoring. It's kind of the most simple factoring that there is. And then we moved up to like medium level factoring, where in probably 6th grade, maybe 7th, you learned how to factor out a number out of this. What would factor out of that? 2. And then you'd have what left? -1. And a lot of times at the beginning we just say, that's it. You know, you factored it. Yay. But now you know enough that that's not done, is it? How could I factor that farther? Yes, this is one of those difference of squares. So it's x plus 1 and x minus 1. All right. And that's handy because then I can see my roots easier. What are my roots in this one? 1 and -1. There's only 2 roots. Does that match up with that? Yeah, it makes sense. There should be 2 roots. All right. This difference of squares came out to this and this. I want you to stretch your mind on your scratch paper. I want you to try this. One of the pre-calc teachers says, that always confuses them. Try that once. See if they do it the right way. Tell me what you think that factors to. I'm going to pause while you do that. Okay, so what do you think? Yes? Yeah, ugly X, but yes, very nice. And how can I prove that's right? Just have to FOIL it out, and I'll end up with the right answer. All right, that's the end of my first section.